video is about functions and their inverses, and so this is just a brief introduction to what functions and inverses do. The next two videos you go through the mechanics of learning the characteristics of them and how to find an inverse of a function. But first let's just talk about what are they. So we talked about compositions of functions in the last video. And so composition of functions is a function of a function. So I drew something like this. We had a regular input-output function box, right? So we'd say what goes into a function is our domain, our x's. So some x value will go into some function f, and what pops out of it is f of x. Okay. And then when we learned about the composition function of a function, what we would do is we would feed this output into, it became the input of some other function here, g, and then what we would get out is g not of x, but of f of x, what we put into it right here. Now, when you talk about inverse functions, that's not just any old g, that's a very special function, one that will completely undo the process. So for instance, here is an example of a function that has an inverse. All functions don't have an inverse, so I need to discuss that as well. But if I say this function is putting this marker in my hand, then the inverse function would be whatever it would take to undo that. So taking the marker out of my hand would be the inverse to that function because it's as if it never happened. So you can think of other examples. Here's a function that has an inverse, walking downstairs. How could you undo that? You could walk up the stairs as if it never happened. There are functions that don't have inverses. If you think, for instance, maybe baking a cake. You have these ingredients. The input to the ingredients are like eggs and oil and cake mix or whatever. And then the output of that function is a cake. What is that process that would undo that? Some people say, well, eating the cake, but that doesn't get the eggs back in their shells and that doesn't get the oil back. There's no real inverse to that process. So, functions that have inverses pass something called the horizontal line test. So I'm going to talk about that in a minute. I'll remind myself to mention that. And functions that do not have inverses fail the horizontal line test. So I'll show you which functions have inverses and which functions don't have inverses. But first let's say, what is it? So let's create a function, a mathy function. I'm going to make one up. I'm going to make up a function that adds the number 4 to whatever comes into it. So this is what it's going to look like. That's what f is going to be. I'm going to create this function called add 4 to whatever comes into it. Okay, so ready? This is going to be x plus 4. So if we were in class together, you would create the inverse. I would say to you, hey, what would totally undo adding 4 to a function? And you all would say to me, subtracting 4 from a function would do that. And so that is what I'll pretend like I heard you guys say, and we'll say, okay, well then let's create this inverse function right here. That what would totally undo that process would be to subtract 4 from that. So we're going to test out our function in inverse. We're going to pick a number in the domain of this function x plus 4. If you notice, x plus 4 is a linear function, right? Y equals mx plus b, the slope would be 1, the y-intercept would be 4. And the domain of a linear function is all real numbers. So we could choose any real number. I am going to choose the number 7. So I choose a specific number 7 to go into here. Okay. So what happens is I say, okay, 7 is going to travel into here. 7 becomes the x. 4 gets added to 7, and what pops out is the number 11. 7, 8, 9, 10, 11. Okay, so then 11 travels down. That's what my f of x is. 11 travels down the conveyor belt. It goes into this inverse function, so it becomes this x, and 11 minus 4 gives me 7. So what we find is when you apply a function, when you apply a function, right, what we got here was x went in here to f, what we got out was f of x, and what we put in here was f of x, right, and what we applied was not just any function g, but a very special one called f inverse of x. That's what we applied what we got out was the original thing we put in or the original x. This is what it looks like in math notation. F of x, the composition of f inverse of x is just x, the original input, or vice versa. F inverse of f of x, the composition of a function and its inverse, or its inverse and its function, is the original input. We did it for a very specific example, for a very specific number, but in general, this is what's going to work. A function and its inverse totally undo each other as if the process never happened. That's what a function and its inverse are. So let's look at something called the horizontal line test right here. Here are some functions that we have seen many times, okay? All right, I'm going to say this is the absolute value function. You guys are familiar with it. This is the x squared. This is the parabola. This is x cubed right here. This is x cubed. This is y equals to x. Oops, sorry. This is a line, y equals to x. This is the square root of x. Oops, that looks a little funny. This is the square root of x, okay? This is 1 over x. This is the reciprocal function, 1 over x, okay? Now, these are all functions. They all pass the vertical line test. I could pass a vertical line through every one of these and it would only hit at one time. It would not hit more than once. That means it passes the vertical line test. That means these are all functions. We already knew that. Okay, now here's the real question. Does this pass the horizontal line test, which I'm abbreviating HLT, which means can you pass a horizontal line through it and only have it touch one place? If you can make it touch more than one place, similar to the vertical line test, right? If you can make it touch more than one place, then it fails the horizontal line test and it is not one-to-one. We call that, if it passes the horizontal line test, it's one-to-one. If it fails it, it's not one-to-one and it does not have an inverse function. Okay, so let's just have at it. What happens when we pass a horizontal line through this? Can we make it touch more than once? Yeah, this one fails. This fails the horizontal line test. It did not pass the horizontal line test. So what I can say is this is not one-to-one. This is the language that we use. This is not one-to-one. How about this guy? Oh no, it failed. No, it hit more than once. This is not one-to-one. What about this guy? Well, let's see. Here, here, here. Anywhere I make it past it, only hit once. Yes, this is one-to-one. What about this guy? Yes, it would only hit one time. This is, yes, one-to-one. Yes, this is one-to-one. Yes, this is one-to-one. What is the significance of it passing the horizontal line test? Then it's one-to-one. Why do we care if it's one-to-one? If a function is one-to-one, then an inverse exists. So what I'm going to do is say, I could go find this, an inverse exists. An inverse exists here, 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 here. What about these guys? They failed the horizontal line test, therefore no inverse exists for these functions. Okay, so this is a very brief introduction to what in the world is even an inverse function. It totally undoes what the function did. And then in the next videos, you'll get to see those in some specific examples.